Now we're going to learn how to find an empirical formula. The word empirical means derived from evidence. There are experimental techniques that can take a compound and break it down into its constituent parts and find out, for example, that 36.5% of it's sodium, 25.4% of it's sulfur, and 38.1% of it is oxygen. From that, we can figure out what an empirical formula is. We can figure out what the ratio of sodiums to sulfurs to oxygens are in terms of the number of atoms, or the number of moles, which is going to allow us to write the formula. Here's how we approach this problem. I'm going to write the steps off to the side here and keep track as I go. The first thing we're going to do is we're going to turn the percentage into grams. I need to find the moles of each thing so that I can find out which one I have the most moles of, so I know what ratios to use in my formula. To get moles, I need grams. I simply assume that I have 100 grams total, which would mean I have 36.5 grams of Na, 25.4 grams of sulfur, 38.1 grams of oxygen. In a problem, you might be given moles. If you're given grams, you just start right there. Step 2. We're going to divide by molecular weight to get moles. To get the moles of sulfur, I divide its grams by its molecular weight. 36.5 divided by 23, 1.587. To get the moles of sulfur, I divide 25.4 grams by the molecular weight of sulfur, which is 32. Just gives me 0.794. For oxygen, I'll divide 38.1 grams by its molecular weight of 16. 2.381 moles of oxygen. I now know that my formula is going to have the largest subscript for the oxygen because it has the most moles, and it's going to have the smallest subscript for the sulfur, but I want to get those numbers exactly. So to find the ratio, we're going to divide all of the moles by the smallest number of moles I have, and that's going to give me the ratio. So my smallest number of moles is 0.794. So I'm going to divide all of these moles by 0.794. Because I want to know how many times more sodium do I have than sulfur. So how many times bigger is the moles? 1.587 divided by 0.794 gives me 1.999. 1.999 is pretty close to what? 2. 0.794 divided by 0.794 is 1. 2.381 divided by 0.794 gives me 2.998, which is pretty darn close to 3. These ratios, 2 to 1 and 3 to 1, these numbers become my subscripts. My formula has 2 sodiums, 1 sulfur, and 3 oxygens, giving me Na2SO3. Sometimes there's a 4th step, and the occasions when you have the 4th step occur when you don't get whole numbers here. If you get something that rather than ending in a whole number ends in something 0.5, what you're going to need to do is you're going to need to double everything. If you get something that ends in 0.33, you're going to multiply everything by 3 to get a whole number. In other words, suppose I ended up with something like, I did the whole problem and I got that N was a 1 and O was a 2.5. In other words, I wouldn't be able to write this as a formula because that's not a thing. We need to use whole numbers. But my ratio, if it ends in 0.5, I double everything. And so instead of having N1O2.5, I have N2O5, which gives me two whole numbers. And a ratio of 5 to 2 is indeed the same as a ratio of 2.5 to 1.